So we have just finished the B.M. Das Memorial Lecture given by eminent Professor Shobha Moitro, and due to time constraint he is leaving now. So we are going our next session of the program. Our next speaker, Mr. Supriyo Sinha, is already here. So before introducing and starting up his lecture, there is a small part of our event which is due. There is a short presentation of the award winners of today's event. I would request one by one the recipients of the award winners to come on the dais and give your presentation in as short as possible. So I request the first candidate, Ms. Sarika Kumari, to give your presentation, please.
Thank you, sir. A warm good evening to all. My name is Sarika Kumari. I am from Bihar. I completed my BTech from the MIT Muzaffarpur, and I got the same award on the 2020 as a topper in a BTech. And at the same time, I am coming for the MTech. I completed MTech from the CLIR in 2022 and got selected for this award. So I am here today. So before I'm going to ahead, I just tell myself how I am proceeding here and what's my now I'm working as a lecturer in Karnataka Institute of Leather and Fashion Technology as a post of assistant professor there with a lecturing there. So now I'm saying one thing, sir, that whatever I got to achieve today, that is not only my hard work and my things. This is firstly I say to thanks to my parents. They give me that opportunity to got this great education, because education is the only one thing that give you the freedom to just unlock the world. So today I just say thanks to my teachers, my family, my friends, and also the MIT where I got BTech and all the staff of CLIR. I say thanks to everyone. And today when I'm in this position, so I just say one thing to all. Whatever I got, the certificate and everything, I just promise to all that the things I have carried, that is not only the medal and the certificate. This is a responsibility in the educational field. So I carry these things and maintaining and give back to the society. Thank you.
Thank you, Sarika Kumari. I now request Mr. Manikandan H.
Good evening, everyone. First of all, I am very privileged to get the award in the name of our former director, B.M. Das, and I thank Indian Leather Technologies Association who have selected me for giving this award. And without any further delay, I just present my topic. I have worked on the topic of circular economic approach to use comb shavings as tanning and retanning agent in leather processing. And recently, the sustainability is a talk of the world, and we as leather technologists are not unaware of that, and we are moving toward sustainable leather processing technologies in leather processing. And my work is just one step towards it. And waste generation is just common for every industry, and we mainly produce solid waste, liquid waste in it, and we majorly produce chrome tanned leathers for the product manufacturing. And this chrome tanned leathers may produce some good some solid waste, and which can be used for some good purposes as well. So there are many applications in the past which we can see in this slide, but the complete utilization of this chrome shavings is not being achieved. We are incinerating it, we are burning, we are dumping these chrome shavings, and but these chrome shavings are proteinaceous waste. These can be utilized for making lot of value added products in leather manufacturing or in other sectors as well. And But in doing that, already there are many processes of utilizing these chrome shavings, but the protein are not being completely utilized there. My focus is complete utilization of these proteins. And we are making as a product as a tanning as well as a retanning agent. It will act as a multi-purpose chemical in it. And this is our plan of work. We do hydrolysis, then we characterize it, then we confirm the presence of CR6, because CR6 is one of the danger chemicals while processing leather. We have to confirm the absence of hexavalent chromium, and then we are preparing this collagen hydrolysate into our product with some adding metals in it, and then we are analyzing this product, and we are utilizing this product in leather manufacturing. Then we are analyzing the environmental impacts in it. And this is our trials that I have taken, and with that I have optimized the hydrolysis process with 14.5% of sulfuric acid and 10.5% of sodium hydroxide. And I have already ensured using sodium sulfide that this hexavalent chromium is reduced to trivalent chromium, so that we don't want to harm the environment as well. So the total CR in our product is around 3.3% as I have mentioned, but the CR6 as I have reduced it, so it is not in detectable amount. And this is our process. At last, the first 4 are our small trials, and the 5th one is our final trial, which I have taken the collagen hydrolysate solution. I have added the metals like zinc and sulfate, zinc sulfate and silica to make it as a complete solution with 1:0.6% ratio. And then we have spray dried the chemical into our product called PRMMO, that is protein mixed metal oxide product. And I have already mentioned that the metal oxide content in our product is around 6%. It is in the ratio of 1:1:0.6. And for reducing the pH around 2.5, I've used silica because I don't want to form neutral salts in it, so that the process will have a lot of impurities. So I used the main chemical as reducing agent. And this is our analysis. In our product, we have it has 62% of protein, so that this product is a proteinaceous product, and the chrome content is around 2.7. And these are around analysis of our product. We can see the silicas present in it using the Fourier transform. And particle size, if you see the particle size of the collagen hydrolysate and the product, you can see increase in the size due to the presence of allied metals which are added during the upcoming processes. And you can see the size of our product is around 653 dnm, which is good for penetration, and we got full through and through penetration of this product through our leather. And potentiometric titration, where 4.8 until 4.8 pH our product is stable. So after application of our product as a tanning agent, we have analyzed the physical properties of the leather which is tan, and these are the results. You can compare with the controlled chrome tan and zirconium tan leather, where it is showing good physical properties when compared to the other leathers. You can see the tensile strength, tear strength, because the protein has a lot of active sites which will bind with the chemicals like fat liquor and other auxiliaries that we are using in post tanning, so that we get good physical properties in it. So this we have analyzed it. So exhaustion amount is around 93%. We got the shrinkage temperature of around 87, which is far better. And but when we compare to the complete chrome tan, because we are using low chrome product, this is a low chrome product. We are not going with 3.3%. We are getting just 2.7, and we are using not 8% of in practice. And analysis of effluent, there is a less pollutants in the effluent that we are generated. And this is a physical testing result. As you already see, the physical properties of leather used in of the leathers retanned using our product is also showing good results, sir. And this I have already said. So the organoleptic properties are also very good when we have analyzed our leathers with the industrial experts. And these are some images of my leather. When we compared with the BCS tanned and zirconium tanned leather, the surface level filling is very good in when we have tanned with our product. And if you look into the cross-sectional image, you can see the fiber compactness of the leather, so that the physical this can be a reason. This can be a reason for the good physical properties of the retanned leather. So we also did a contact angle measurement, and we got that the leather tanned is hydrophilic. So to end, the leather tanned with our product exhibited good physical properties, both when we used as a tanning agent as well as a retanning agent. And we produced pastel colored leathers. We don't go with dark shades, like because we opted chrome tanning for pastel colored leathers for the product manufacturing, and my product is very much useful in it. And the development of such product from the chrome shavings and trimmings have promising approach towards waste management. And for sustainable leather manufacturing, this is just a one step towards it. And these are my references. Thank you so much. I thank my professor, Dr. B. Madan, who guided me throughout this project. Thank you so much. Thank you, ILTA. Thank you.
It's a nice lecture. Presentation by Mr. Manikandan H. We have a sort of time, so I request the other audience to make their presentation short. If it is acknowledgement is fine. If it is a presentation, please make it a short. I invite Mr. Venkatachalam T.
Good evening, one and all present here. First of all, I thank ILTA for giving me this opportunity to present here. So my topic is based on studies on the development of supercritical carbon dioxide based vegetable tanning. Actually, leather, as you all know, that leather has been used as a various products like upholstery, garments, glove, etc. To manufacture 1 kg of raw hide and skin, you need to 25 to 30 liters of water. As well as the effluent which it is generating from the leather industry has been untreated, it causes major concerns. So I have chosen water is used as a medium in leather industry, as we all know that. Instead of water, I am using supercritical carbon dioxide as a medium. So the need for the study is to replace water using the tanning, as well as to reduce the effluent load in the leather industry, leather processing. So why supercritical carbon dioxide? First of all, supercritical solvents are nothing but whenever a solvent reaches a critical temperature and pressure, it achieves supercritical state. So why specifically supercritical carbon dioxide is that, apart from other solvents, supercritical carbon dioxide achieves its critical temperature and pressure far better than the other solvents. It achieves at the rate of 31 degrees Celsius in the temperature as well as 70 bar pressure. So this is a phase diagram of supercritical carbon dioxide, where you can see the solid phase, liquid phase and the gas phase as well as the supercritical phase. So as I already said, that supercritical carbon dioxide is environment friendly, as it is no carcinogen, as well as it is less polluting to the environment, and we can recirculate the supercritical carbon dioxide for other leather processing. So this is the supercritical carbon dioxide facility in our institute, where you can see the mixing vessel, processing vessel as well as the separating vessel. The mixing vessel is the one where we insert our chemicals, the processing vessel is where we insert our skin matrix, and the separating vessel is the one where we separate the gas as well as the chemicals which we are using in the leather processing. So my work is to use vegetable tanning agent in the supercritical medium without using water in the tanning process. So first of all, my work design is to choose the suitable vegetable tanning agent as well as optimizing the supercritical carbon dioxide and to compare it with the conventional leather process. So these are all the process which I have carried out by taking different vegetable tanning agents like Cubracho, Myrobalan and Wattle. So these are all the processed leathers. Compared to the processed leathers, Cubracho tanned leathers shows better properties. So I have chosen Cubracho tanned leathers for supercritical carbon dioxide medium. So at the pressure of 80 bar and 35 degrees Celsius, Cubracho tanned leather shows good uniform penetration as well as good shrinkage temperature of around 75 to 80 degrees Celsius. So after that, I have optimized the chemical composition of water, temperature as well as the acid mixture to avoid the pickling process in the leather tanning, as well as the consumption of water has been reduced. So to optimize it, I have chosen from 10% to 50%, as well as the Kubracho ratio of 5% to 30%, and the acid mixture of 0.1 to 0.4%, whereas the acid mixture comprises of sulfuric acid as well as formic acid. So this is the process flow where I have taken the conventional delimed process and the delimed belt has been stepped into 3 different processes where without using supercritical carbon dioxide, with supercritical carbon dioxide, and the conventional vegetable tanning process has been carried out. After choosing this vegetable tanning process, I have tried without supercritical medium as well as with supercritical medium. So as you can see the image of the processed leather inside the supercritical carbon dioxide vessel, the delimed pelts are directly taken into this process and the composition which I have mentioned has been inserted into this process. Composition of 20% Kubracho, 0.4% acid mixture and 10% water has been used. So this is the process flow without using and with using supercritical carbon dioxide medium. As you can see the crust leather with good dyeing and penetration of chemicals. So this is a morphological analysis of SEM and cross-sectional and grain images of 300 micrometer. As you can see the conventional and the experiment leather shows good surface images. So physical strength properties are also comparable with the conventional one, and some properties like tensile strength are far better than the conventional one. So organoleptic properties like grain tightness, smoothness, fullness and overall appearance are also comparable with the conventional vegetable tanned leather. So analysis of different chemical constituents in the vegetable tanned leather like moisture content, solvent soluble, water soluble matter, insoluble ash, height substance, fixed tannins and degree of tannage has been measured, and it is also compared with the conventional one, it is better than the experimental. So by optimizing this process we can reduce the chemical as well as elimination of pickling process and the consumption of water, and we can reuse the carbon dioxide which we are going to use in the supercritical medium, as well as the time has also been reduced. So we have tried different pH in the process of supercritical carbon dioxide achieving this process. So by using the supercritical carbon dioxide medium, we can achieve a low water tanning system by using only 10% of water, as well as elimination of pickling process where a huge amount of total dissolved solids has been generated, and the consumption of water and reusing of supercritical carbon dioxide has also been achieved using this supercritical medium. Once again, thank everyone for attending my lecture, listening my lecture. Thank you.
Thank you, Mr. Venkatachalam. Now the last recipient, Ms. Kritika Bhagmi.
Recral fungal growth on leather is a various leather industrial problem nowadays. Do you think that chemical antifungal agent can reduce it? No, obviously not. We need biological antifungal agent. So hello everyone, this is Kritika Bhagmi from GC ILTA College, Kolkata. So my project was antifungal screening of methanolic extract of phytochemical for producing antifungal agent. So nowadays leather industry is facing so many problems. The leather industry is facing so much problems. Leather has so much fungal outgrowth. So for reducing this, I have made the antifungal agent from biological origin. This origin is from, you can see I have taken these 3 samples. These are curry leaves, hibiscus leaves and drumstick leaves. The methanolic extracts of these leaves were made and they were quantitatively and qualitatively analyzed. The objective was to just find out that what is the antifungal property which is in that leaves. So zone of inhibition, MIC, various things were taken for the analysis. We can see that there are quantitative analysis in which we have done peroxidase assay, total phenolic content, Bradford assays, and there is also a qualitative analysis in which we have done tannin test, terpenoid test. These all for the test that what is the antifungal property which is within these leaves. And we can see that there are various results which has been obtained from the experiment. So in short, we can say that these antifungal agent can be used in leather industry, and after analyzing all those data, we can say that we can use the biological antifungal agent. So this aim was completed that we can using the antifungal agent as of biological origin, and we don't need to take chemical antifungal agent. So it will basically reduce the environmental impact and nature will be good for this. And one basic result which I obtained that the higher concentration of methanolic extract which I was using was more sufficient and more good for as an antifungal agent. So thank you very much. Thank you, ILTA and everyone.